But if I can create a triangle, then questions about trig values are simple. They're just ratios of sides of the triangle, right? The right triangle. So, the equation they give us, did I leave? Of course I did. Let's see, none of you work, I don't think. That sucks. I left my markers in my last class. Alright, so let's see if I can make something work here. If not, I'll just use the overhead. This sort of works. Which one is it? 55? So let me do one like it. I'm going to do 54. You can almost see that. I got a little handout that I'm going to have you working on. While you're doing that, I'll run and get a better marker. It just sucks when I leave my markers behind. So 54 says equals 0, x less than or equal to 0. And it wants to know the equation, sketch the least positive such angle theta. Yeah. And find the values of the trig functions. Okay. Can you graph this equation is a good first step. How the hell do I graph that equation? Well, here's a nice thing you could do for yourself. You could solve for y. That would make things a little easier, because then you have the input and the output. It makes a little more sense, right? So how do I solve this for y? Add 5x. And then I divide by negative 3. I like it. Okay, maybe. Yes?
Could you use matrix multiplication to solve it, or no?
Matrix multiplication. How?
So like on my calculator, you can input for different variables, like -4 for the first column.
Oh, you don't mean matrix, you mean table. You mean, are you saying plug this into y1 and have the calculator make a table for you?
Not like a table like that. There's a way you can like make like for like different variables, like for the first column would be x, second column y, and the third column z. Or you make it with perfect variables.
You do not need a third variable here. Now, am I saying you can't do it that way? No, you could probably do it whatever way you're talking about, but that's making it way more complicated than it really is, right? Okay, I'll have to see what you're saying after class, because this is nowhere near anything I would consider needing matrix multiplication, right? Okay. What kind of x's does it say I can use in that problem? This is number 54. Yes, I like it. So let's make a little table of values real quick. When x is 0, what's y? 0. When x is, let me see. Let me see if you guys are cool with this. I'm going to get a fraction for almost any input. Do you agree? Mm-hmm. Except for, like if I plug a 1 in, I'm going to get a fraction. If I plug a 2 in, I'm going to, what can I plug in and I don't get a fraction? 3. So I'm going to plug a -3 in. What do I get when I plug a -3 in? -5/3 times -3?
Positive 5.
Positive 5. Hold on. You guys with me? Let me stop for a minute. So there's various parts of this problem. One part is graphing the line. The other one is realizing they only want me to use negative x values, right? So now if I graph this thing, I'll get 0, 0, -3, 5, right? So can you see the triangle?
Yeah.
And something they don't really say well in this is that the angle has to be with respect to the x-axis. So do you see how that would be this angle? Is that angle in the base of the triangle? Is that a right triangle that I just drew?
Yeah.
Totally. This is parallel to the y, parallel to the x, so that's a right triangle right there. Now all I need to know to figure out all the trig values is what are all the sides. Here's something really kind of cool. Remind me, sine likes what again? Y. So where will sine be positive? Where's the y positive? And let me remind you, what are the quadrants? This is the first quadrant, second quadrant, third quadrant, fourth quadrant. So where will sine Where will sine be positive?
Quadrant 1 and 2.
Booby trap.
Yeah.
Yeah, quadrant 1 and 2. I love it. Do you understand? SOHCAHTOA doesn't do shit for you with that. If you know sine likes y, you know sine's going to be positive in the first and second quadrant. Where's cosine positive? Cosine likes x. So what quadrants? 1 and 4. Kick ass. You guys with me? Tangent is which trig divided by which trig?
Y over x.
No, which trig divided by which trig?
Oh.
Y likes
Sine over
so
cosine.
sine over cosine, right? So when is tangent going to be positive when sine and cosine are the same sign?
1.
Because it's a ratio of them, right? Sine and cosine in the first quadrant, are they negative or positive?
Positive.
They're both positive. Where else are they both the same sign?
Quadrant 3.
Because in quadrant 3, cosine likes x, it's negative. Sine likes y, it's negative. So what will tangent be in quadrant 3? It'll be positive, because when you divide. And of course, these two, sine and cosine, are different SIGNs. Right? Kind of sucks we have something called sine, S-I-N-E. Okay. Maybe. So right now, this is a little tiny bit weird, but this is why I like to start with sine likes y, cosine likes x. We're going to bring in the idea of angles that don't live in triangles necessarily, right? If I say the sine of 45 degrees, it is a number. It doesn't need to live in a triangle, but we start with triangles to make them make sense. So, can anyone tell me, now if I ask you how long this side is, how long is this side? 3. Realize that if I say negative 3, won't cosine be the right sign then, the SIGN?
Yeah.
Isn't cosine supposed to be negative? Because this is actually 3 back, correct? So what's this? Is this 5 or negative 5?
5.
Obviously it's 5. Become a 5. All right, I'm sorry guys, I'm going to have to get some more markers. How do I get the last side? Because I need it. What's the one trig I can get already for this angle? What trig?
Tangent.
I can get tangent. What's tangent?
5 over negative 5 thirds.
Yeah, and 5 over negative 3, so negative 5 thirds. Is everybody with me? What's cotangent?
3 over negative.
Yeah, negative 3/5. That kicks ass. Why can't I get anything else?
Because you don't have the
Everything else requires the
hypotenuse.
hypotenuse. And how do you get the hypotenuse?
Pythagoras.
That's right. That's right. Sorry. Are you guys kind of with me?
Yeah.
How would you get that side then? What would you do?
Square 3 and 5.
5 squared plus negative 3 squared. What's that? 25 plus 9 is 34, and then square root that. And then you just make the ratios for sine, cosine, and then of course you flip those for cosecant, secant. Are you guys semi with me? I know we just went over this, but it's actually really silly if you've never seen trig before to realize that's all the shit they are, is ratios of sides of triangles. And we just gave them names. The names kind of suck right now. They just do. I'm sorry, it's just the way we did it. Sine theta is related to cosecant theta, right? You with me? Okay. Are you guys with me for real? Okay.
Yeah.
So real quick, what would sine theta be?
5 over. Well, actually, you have to rationalize.
Yeah, it'd be 5 over. Go ahead. First step would be 5 over
Rad 34.
rad 34, right? Y over r. And then you have to rationalize it. I love it. So it'd be 5 rad 34 over 34. What would cosecant theta be?
Rad 34.
Yeah, you just start here. Flip it, right? Because it's just the reciprocal of sine. Is everybody with me? Let that be nice right now. Will it remain that nice? No. But the basic definition of cosine, sine, all that kind of stuff, especially when you have a triangle, stupid easy. We're going to build what those values are, absence of triangle, using triangles. So it's still going to be based on triangles fundamentally. We're going to do that today, eventually. Is that better? So every single one of those problems, the very first step is graph the thing. Be careful about what x's they say you can use. And then it's just the smallest angle that goes to the x-axis. So it's not this one, because this one's smaller, right? Yes?
How would I know if like I needed you? Because basically the distance formula is like the square root of x minus 1.
x2 minus x1 squared plus y2 minus y1 squared.
Yeah, and then they're saying to use r equals x squared plus y squared. How would I know when to use which?
So the funny thing is, can somebody, all right, this is getting a little ahead, but that's fine. Can somebody define a circle for me? This is something you might never have thought of directly. How would you define a circle? Like someone's got a circular shape. No, it's no good, right? It is a collection of points. Every point has a similar property. Every single point on a circle has the same property. Equidistant from the center. You with me? All right, go with me for a second. This is why I wish I had a better freaking marker, but I left them all. So let's see if you guys can. Oh, let me just put it up here. Screw this shit. Damn, I cussed. I'm so sorry. That was just for me. Let's see, I need paper. Didn't know I would need paper. All right, here we go. What are you doing? You're done. Great. This kicks a lot of ass. All right. This will be something we will need very soon, so I don't mind doing this right now, because it just happened to come up. So let's say we have the center at 0, 0, right? Oops, where am I? There. And let's say I've got this circle, right? Pretending this is a circle, centered at 0, 0. And I've got a point on the circle. I can put it anywhere I want to, it doesn't matter. Just a point on the circle, x, y. Is everybody with me?
Yeah.
Become a... Okay. Today's lesson brought to you by the Optometrist of America. What's this point?
0,
0, 0. How far apart are these 2 points?
Y minus 0.
Now, one way you can say is the radius, right? You with me? But real quick, if I use the distance formula, let's use the letter r instead of d, because now r is radius, right? So r,
Equals
sure, r squared equals, what's this?
y squared plus x squared.
Yeah, it would be y squared plus x squared. That is the equation of a circle. And it comes from the basic definition. So very often, if you can say in English what a function looks like, you can get a formula from it. Every point, doesn't matter where I put the point, it'd be the same idea, right? You guys all with me? So when do I use this is if I'm talking about a circle centered at 0, 0. When would it be different than these if the center is not 0, 0? Or if I just have 2 points living in space, and I wanted the distance between them, then I just plug, I would just plug 7 minus 3 squared plus 4 minus 1 squared, right?
Right.
You with me? Do you see how that's the same thing we did here, except here it was just x minus 0, y minus 0. It's the same thing. Okay. Because it was 0, 0 was one of the points. 0, 0 being a point kicks ass very often. Right.
Okay.
Okay. Is that good? Okay. So let me do this. Let me give you guys something to work on for a bit. Let me make sure if you need anything, you should be able to do all this. Yes.
So the question said, for the least angle, is it like the angle you chose?
Relation to the x-axis is what they didn't really say well.
Oh.
Yeah. So the smallest angle that it makes related to the x-axis. I think they tried to say it, but it wasn't really clear. Yeah. All right, so I'm gonna give you this. I want you all to try it out. It's not a quiz or anything, you can work together. While you're doing it, I'm gonna get some better markers.
For
120 and 1.3.
it's in the 1.3 work problem 110.
110. Okay.
Thank you.
Anytime. So real quick, somebody had a question about 1.3, number 110. Let's see. Let's see, it says, angles 25 and 65 are complementary because they have to be 90. Determine tangent 25 and cotangent 65. So that's where you can just, in your calculator. So if you have the TI calculator, you can just do tangent 25, cotangent 65. I forgot that they put calculator usage in 1.3. They go over something important when you do use your calculator. I think they do. Do they? Maybe not. Real quick thing about the calculator before you guys start on that handout. What's kind of unfortunate right now is, and I'm not quite teaching this class the way I would really like to because I'm trying to stick with the book a little bit more. Degrees, real quick guys, go with me for a second. Degrees are completely made up. Did it have to be 360? Is there any physical reason why it had to be 360?
No.
Why do you think we chose 360?
Is it the year back is remember?
Huh?
Because they consider 360 a year back.
Yeah, we stole it from the Babylonians who used 60 as their base for the number system because they liked the number 360 because it's almost the length of a year. That was important for ancient civilizations because it was all guided by what time to harvest. So obviously how long a year is was important. Okay, still is. So we stole a lot of stuff from the Babylonians. 360 also just happens to be factorable in a lot of ways. You with me? But it's completely freaking made up. It could have been 400. We could have just sliced it up into 400 parts. It could have been 20. Could have been 2. 1, 2 degrees. You know, it could have been 2. Why not? That would have been freaky, but it could have been. So part of what we're going to do later this semester is we're going to determine a better unit than degrees. We're going to determine a unit that's based on physical reality of the circle. Not just, I like the number 360, but an actual physical reality of the circle. That's a better unit to use than just like some number I pull out of my head. Or we pulled out of the Babylonians. But in your calculator, right now you don't have to fully understand this. But if I wanted to try to do tangent of something, see there's the tangent button, right? So if I put tangent of 18, can everybody who has a calculator do tangent of 18? Let's see if we get the same answer. Did some of you not get that answer?
Yeah, I didn't.
So here's the thing, you're fine. Your calculator is not having an episode necessarily. I don't know, maybe it is. Do you see the mode button right here? Mode. Okay, what's really important right now is, do you see this fourth line down? See where it says degree? The other unit we're going to learn later is called the radian. So your poor little calculator, you got to tell it what the hell 18 is. Is 18 degrees or is it 18 radians? If you've never heard of radians, you're fine. You don't have to know what they mean yet. But when you're doing a calculator problem to calculate what tangent values are for degrees, you got to make sure it's in degrees. So if I put this into radians, I'll get the answer some of you guys probably got. Jeff, there you go. Did some of you guys get that answer?
Yeah.
Okay. So that's if I was using radians. So degrees would be like maybe, here's the idea, right? 57 degrees roughly is 1 radian, and we'll learn why later, right? All I need you to know right now is if you're going to throw degrees into a trig function in your calculator, make sure you are in degrees. Go down to it, highlight it, hit enter. Is everybody with me? Yeah. Okay. So I'm going to grab some better markers. You guys work on that. You can work together if you want to. And when I get back,